Okay, Math 10, we're back, and we're going to be taking a look finally at graphs. We have been saying that this is going to be about graphs this chapter, chapter 3. We haven't really seen a lot of graphs yet, so here we are. A graph is really a way of showing a whole lot of ordered pairs in a picture, and it's amazing what happens when you do show it as a picture. You get a lot better understanding of what's happening in the relation. So if you were to look at some of these mapping diagrams, okay, they're good, but there's nothing like a picture to show you what's happening. For example, if this line here, if the x-axis, the variables were your, hours you were working, and this was your paycheck, you could see, oh, your paycheck's going down. I don't think you actually work negative hours, though. I'm not too sure what that would mean, but you can get a sense of what's happening to your income by looking at this downward thrusting line. Hopefully that's not your income if that's the case. So these are sort of visual representations of relations. They are made up of ordered pairs. They are, the same thing as the mapping diagram, but in visual form. So it's a new way of I guess it's not new, you've seen it before, but it's another way of representing a relation. So we still have things like domain and range, but for a lot of these graphs, they go into the infinite. So when we talked about domain and range of a relation like this, there's only 3 ordered pairs. There's not much to say about the domain and range. So when you have a graph, you might have a lot to say. There might be a lot of possible values for x. In fact, see how they have the arrows? I'm going to try and zoom in. Wish me luck. There we go. Zoom in. See how it's got an arrow? That means it continues on for infinity, all the way to, it never stops, basically. This also never stops on this direction as well. So if you have arrows on the end, that means it just keeps on going. So that means our domain is basically going to include all the x values because it's going to keep on going to the left. It's going to keep on going to the right. Same for range. It's going to include all the y values as well. That includes all the decimal numbers, all the irrational numbers, everything. So what we can say for question 10a, when we're asked what is the domain and range, well, in this case, it's going to be domain is, we write it as all real numbers. I'm not sure why my pen turned into this spiky writing. It looks like I'm writing some kind of vampire fan fiction or something, but it's okay. We'll just give it a rest. So all real numbers because it's got these arrows that go forever, and there's no break in it. It's solid, right? It just continues on. So same with range, all real numbers. So that is a perfectly valid answer, and it's, honestly, it's going to be a real common answer. For question B, it's a little bit different, though. It's not all real numbers. It's sort of similar, right? Except that it's not connected. It's only these dots. They go on forever, so it's going to be dots forever, but it's not going to include the information that's in between. It's not going to include these numbers. So really, it's just the integers. So what you can say is all integers, or just integers is a perfectly fine answer. It's going to be all the integers. They're all covered here. If you look, 1 is covered here, 2 is covered, and so on. And we assume it's going to go on forever, so we can just say it's the integers. This is going to be true for domain and range. They're the same. Okay, so that's the deal. Let's take a look at some ones that might be a little bit on the different side. Here's one where they go forever, and it's not broken, but it's got a curve. This is called, by the way, a parabola. Oh, I don't know why my words are turning into spikes. A parabola. A parabola is a really, really common type of relation that you're going to see. They're called usually quadratics, and that's sort of where the factoring came from. X squared plus 2x, or I guess I put x plus 1 or something like that. These kind of things make parabolas. So we're going to be seeing that a lot in grade 11 especially. Not so much in grade 10, but just be aware that that's, this type of relation. I guess I need to have a y in there actually, sorry. So y equals x squared plus 2x plus 1 or something. That is going to be producing this kind of a curve. So what's the deal? So we got the infinite arrows going on, so we know it's going to keep on widening out and forever. So domain is going to continue onwards. So that means it's going to be all real numbers for here. All real numbers. Sorry, my my filter, whatever, I don't know what it is making it spiky. What about y values, the range? So the range, it's going to keep going up forever, as we see from these arrows, but it's kind of bottoms out at y equals 1. So what you can just say, instead of like listing these numbers, you can just say y is greater or equal to, oh, sorry, I'm thinking programming, greater or equal to, in math, looks like this, greater or equal to 1. Because that's all the numbers above this line here are described by this statement, right? 5, 7, a billion, like those are all numbers that are greater or equal to 1. So that's a good way to write sort of the range for this type of thing. Here's a weird one. This one is kind of bizarro. It's got what are called asymptotes. Asymptotes. So asymptotes are basically values that this graph can never get to, but will approach. And so we have one asymptote that is the x-axis, and they don't have to be axes. They can be sort of anything. This is y equals 0. And notice that it's going to get closer and closer, but it's never going to quite touch 0. And there's also this asymptote here, which is x equals 0. And it's going to go closer and closer, but never quite get to that value. So these are asymptotes, and if you see that on a graph, then you can include that in your domain and range. Basically, the domain is going to be all the numbers, right? We have infinite arrow going to the left. We have an infinite arrow going to the right. So it's going to spread, to all the negatives and all the positive numbers, but it's not going to get to 0. It's just not allowed to be 0. So instead of, writing all real numbers except 0, you can just say x not equal to 0. So any number that's not 0 is good. That's what that statement says. So this is, I don't think I drew that very neatly. Let me try again. That's a not equal sign. So we got x, and you have an equal sign with a line through it, not equal to 0. That is the domain. So, is 7 in the domain? Yeah, for sure, it's not 0. Is a million in the domain? Absolutely. -4? You bet, it's not 0. So that's a way of describing that kind of thing. Same with y. Y has a similar asymptote. It's like this line where the graph is approaching it, but never quite gets there. It's got that infinite arrow to say it's always going down, and it's infinitely getting closer to 0, but it's never going to quite reach it. So we say the same sort of thing. Y cannot be 0. Any other number is cool, but not 0. And we got a whole bunch more for you to try out. So some of these I think you might be able to do without too much trouble. Just kind of look and see sort of where these values are lining up to figure out what your domain and range is. Remember, domain is x and range is y. Watch for asymptotes. There's going to be an asymptote right there. So watch out for those. More asymptotes going on here. Here's an asymptote. H has got, oh, that's an interesting one, hey? It's got an asymptote right here, but it's got one sort of right along number -1 and +1 as well. So watch out for that set of asymptotes. Here, oh, that's kind of weird. It's not like curve or anything. So you can see like the range is bottoming out and topping out, and the infinite arrows are only kind of going this way, right? The infinite arrows are telling us going that way. So they're not infinitely increasing up and down. So the domain and range will be different on this one. This question, hey, wow, there's an infinite expansion to left and right, but it only ever has one y value for all these points. All these points along this line only have one y value. So consider that for your answer. We got a bunch more. When we get to K, I want you to know about the difference between a dot that's solid and a dot that's hollow. So a dot that's solid means including. Sorry, I'm trying to write my best here. Thanks. Includes. Oh my gosh. And then does the empty circle does not include. So kind of up to but not including. So for this one, I'll do this one together. It does include this value here, but it doesn't keep going on forever. It stops. There's no arrow, right? So it starts at -2, and it includes -2, and then it goes all the way up to but not including, what is that? 1, 2, 3, 4, +4. So it's all the numbers from -2 to +4, but not including +4. So the way we can write that is, I'm going to move my 4 over a little bit. You put x in the middle, so you can say all the numbers that are, I guess, where x is greater or equal to -2. So that's great because, -2 is greater or equal to -2, and so is, -1, 0, and so on. But then we want it to go up to, but not including 4. So you put the less than sign here, less than 4. So if a number sort of satisfies both those things, then it is in the domain. So like this number here is good. It is number 2. 2 is greater than -2, and it is less than 4. So that's how it does it. But something like 4 isn't part of this, right? It's an empty circle. And 4 isn't less than 4, so it doesn't get included in there. So just so you know, the includes means you're either going to use a greater than or equal to or less than or equal to sign. The empty circle means you're going to be using less than or greater than, depending if it's on the left or the right or the top or the bottom. So watch out for those. This one's probably pretty straightforward. I don't know. Let me know if you have some problems with that. Notice which direction the infinite arrows are going. This one is kind of weird because it says pi, but that's okay. Just go with it. And think about from trigonometry what might be going on here. What curve is this, I wonder? And over here, again, we have an empty, a dark circle and an empty circle, so watch out for that one. We got a few more of those here. Empty circles here, so think about what that means for you. And then we got dark and empty circles here. So there you go. Those are I think that's all the questions for section 3. So thanks so much for your hard work. Sorry, section 3.1. So thanks for your hard work on that. Do let me know if you have questions, if any of these questions don't make sense. Do check your answers. Always, always, always check your answers as you go at the end at least. And then thanks for handing that in on Teams by Tuesday night. Okay, thanks so much, Math 10. Take care, and I hope this was a good first lesson back in 2021. Bye.